Welcome to this very brave new episode of A Shot in the Arm podcast Season 2. I'm Ben Plumley, and this is a podcast about global health and human rights, particularly how we make sense of biomedical innovation and apply it to our daily lives. We explore upcoming scientific advances, innovations the way healthcare is delivered, and we consider the impact that they might have on our societies. How can access to biotechnology for the many, not the few, enhance respect for human rights, rather than threaten people already at the margins? It's about how science strengthens us, not weakens us. This episode is about preparing for pandemics. We're launching this new season on World AIDS Day 2019, and there's no question that the AIDS epidemic has transformed the way the world responds to outbreaks, perhaps as much or more so than Ebola or influenza. The lessons we've learned and the experiences that we've had ourselves are invaluable tools, because AIDS is not over. Whether you call it getting to the last mile or preventing a second wave of drug-resistant HIV, over the next generations, the AIDS epidemic is going to demand so much more of us. But it's also informed a great flowering of clinical research that we are witnessing around us. New diagnostics, new therapies, and the potential of harnessing our immune system to fight infection. So this week, we boldly go to the frontiers of medical science as it seeks to prepare us for the next global pandemic, whether it be the return of diseases we know too well like TB, flu, and HIV, or whether there are new uncharted diseases that, combined with growing urbanization and climate change, are just around the corner to terrorize us. Our guest today is Cristina Tato from the Zuckerberg Biohub. We're going to explore how biomedical science can be a force for good in the 21st century, more so than it was in the 20th century. And remember, pandemics are nothing new in human history. As a collective, humanity has, most of the time, adapted, contained infections, and then continued its rapid population growth. But that does not mean we can be complacent. Besides AIDS, we have some other lessons from history that should help us navigate the future. The Black Death, the bubonic plague that devastated Asia and Europe in the mid-1300s. Two interesting facts strike me about it. The first is that researchers estimate that it took 200 years for the world population to reach its previous levels. So that speaks to an intergenerational resilience, not an emergency that can be rectified immediately. And the second thing is that particular virulent outbreak of the bacterium may actually have been triggered by a change in the climate in the drying grasslands of Central Asia, sending flea-infested rats to more hospitable, damper regions that were also occupied by humans. And what about influenza? And by the way, I hope everyone has had their seasonal flu shot. Barely 100 years ago, the world witnessed the first pandemic of H1N1, a virulent strain of the flu. Starting immediately after the end of World War I, H1N1 spread rapidly. Many governments tried to suppress news of the outbreak. We only call it the Spanish flu because newspaper reporters in Europe and North America were able to report the spread of the virus in neutral Spain. And so, in the public eye, that outbreak of H1N1 was associated indelibly with Spain. The point here is that even as recently as the last 100 years, a pandemic can occur and it can exploit how we seek to control the information we share with each other. In that regard, it seems to me to have strong similarities with HIV, and it's hugely relevant as we enter the 2020s. Because there have never been so many of us. Our current population stands at 7.7 billion. Our environment is under extreme pressure caused by our own behaviour. Will nature bring upon us another pandemic to cull our numbers, or will the rapidly expanding field of scientific knowledge protect us? Well, we've never known so much about the bacteria and viruses that cause pandemics. And to help us make sense of this, and to learn a little more about the potential of a new golden age of clinical science, I'm delighted to be joined by Cristina Tato, who is the Associate Director of the Zuckerberg's Biohub's Infectious Disease Rapid Response Program. Cristina, welcome to A Shot in the Arm.
Thank you.
Well, it's really great to have you here. And I guess the first question is, can you tell us a bit about the Biohub and how it differs from the Zuckerberg initiative?
Yeah, it's a question I get a lot. It's a bit confusing for people. But we are two separate and independent organizations. So we're sister organizations, but we're totally organized and run as separate entities. And primarily the Zuckerberg initiative really has a much larger area of work than we do at the Biohub. They're focused on social justice issues, policy and advocacy, education, as well as science. However, the Biohub, we're really a small medical research organization. We're a nonprofit, and we really focus on basic science. So we want to understand the mechanisms underlying disease so that we can develop methods and technologies that can really advance both research as well as clinical practice.
I think one of the things I found so interesting about the Biohub is the enthusiasm and confidence that it has. If the technology isn't there, we will invent it. And that seems to me a very different take on the world view that we have at the moment, which was more about how do we minimize our imprint and our impact. So is that a really conscious thing, that enthusiasm and confidence?
Yeah, absolutely. There was a definite effort to be made to bring people together that were from different disciplines in science to interact and work on projects and questions from their side of things to kind of bring the creativity and innovation to them.
Well, I think it's very interesting. And the other thing that strikes me, and I've mentioned this in previous podcasts, is that unlike the Gates MRI over in Boston, which really took the best minds from the private sector, the Biohub has really focused on academic partnerships and brought the brightest and best from academia. And so how do you see that contributing and helping drive forward the kind of enthusiasm that we've just spoken about?
Yeah, I mean, so the Biohub was actually literally formed to be a hub of collaboration between the three major universities in the North Bay here, so Berkeley, UCSF, and Stanford. And so the whole point to kind of feed into that basic science focus was to bring together these academics that were, again, from different disciplines and were the best and brightest at their institutions to work together on projects that they would not normally have done so if they hadn't met each other.
Mm. And here you are. So maybe a little bit about you, if that's okay. When did you decide you wanted to be a scientist?
So in a previous life, I actually was in public health originally. And so,
I'm so sorry.
So I worked in policy and education. And doing that work, I actually really dove into the primary literature. And so I really got into the science behind the things that I was talking about and the kind of the policy that I was working on. And so that really kind of drove my curiosity and interest into becoming a scientist and to want to do to do that research myself. And
you got your PhD at the University of Pennsylvania in immunology. And then sort of a circuitous route, you ended up in Stanford. And there are a couple of things I wanted to ask you about that. Do you feel there's something different about the culture on the West Coast, a sort of, oh, my colleagues are going to kill me for saying this, but sort of perhaps a more openness and creativity, less structure, let's say, than there is on the East Coast?
Well, I mean, I was born and raised on the East Coast, so I may be a little biased. I think there's a ton of actual innovation happening on the East Coast as well, especially like in Boston and Durham, if you're talking about biotech and research in that area. But there's definitely, I think, the idea of what Silicon Valley kind of became, right? What the semiconductor industry brought here is definitely a movement that has carried on here very well. So,
and then how that has sort of interacted with the biotech or biopharmaceutical work. And, it has really struck me that the San Francisco Bay Area is really a beating heart of biotech in a way perhaps the world hadn't envisaged or understood. Mm-hmm. So your PhD, and excuse me if I trample on this with layperson's simplicity, was in transcriptive factor families. And if I understand it correctly, these factors are what it sort of essentially help DNA unpack themselves, get into RNA, and then make copies of themselves back into DNA. Could you explain a little bit about that? Well, first of all, did I get that right?
Pretty close, actually. So transcription factors are basically molecules that when they get activated, they go into the nucleus and they have a specific area of DNA that they bind to, that they're specific for. And that's usually in front of a number of different types of genes, specific genes that you want to start making copies of. And so once the transcription factor does that and you get this messenger RNA, you might have heard of that goes in, and that then becomes the template for a protein to be made. And so really the transcription factors are there to help the cell make the proteins that it needs for whatever job it needs to be doing at the time.
And so why is this important? It sort of helps strengthen the immune system, and these processes can, I suppose, both make incomplete copies and therefore perhaps open the immune system up to disease. But presumably they are also targets for novel treatments as well.
Yeah, so a lot of these different transcription factors, some of them are literally called master regulators of the immune system or the immune response, because they will focus the immune response to do a particular thing. So they will change a T cell to do one particular job versus another particular job, depending on what pathogen or what infection you might have. And so, they're super important in immunology. They're super important for allowing the immune system to respond properly to an insult or challenge of an infection. And if things can go wrong, so you can have too good of a response and you can get too much inflammation or dysregulated inflammation as in cases of autoimmunity.
We were talking earlier and I told you that I have Crohn's disease, which is an autoimmune disease. And that, that's from as my mother says, a faulty immune system that has nothing to do with her. But I was at a patients' education forum a couple of weeks ago, and it was really interesting to me that there is a flowering of research, really in the last 20 years. And while that is happening, and we're moving beyond, the mass prescriptions of prednisone and other steroids, we're really at the start. It really feels as if it's sort of a medieval age of understanding of the immune system. Do you see it that way, or do you think we're more advanced?
I think we're definitely getting more advanced than that, but I think the ability to harness the immune system to either help it do its job better or to keep it at bay a little bit when we need to, I think is just at its beginning. There's a number of immunotherapies that are coming out, especially for cancer, that are really on the cusp, I think, of doing some really cool and great things and to help people. And so I think we're at a really interesting, exciting time now, specifically in immunology, for the potential for what we can do.
And the other thing that, bringing us back to the West Coast, that struck me as I was preparing for this is that, and this is more a question of language rather than the science, but there seems to me a great similarity with what is happening in the tech industry. The language, transcription, coding, the binary nature of switching cells on or off. There's a lot of similarity in the way we see the world. And do you think our understanding of immunology is being influenced by the way we develop software? And I'm thinking of the way we perceive the world.
Yeah, that's an interesting question. I mean, I'm sure any mathematician will tell you math underlies everything, right? The way we think everything in nature. And certainly the binary number system, right, pre-existed any cell theory that we ever had. So you could say that, we've copied everything from mathematics. But I think when you think about the first silicon chip and when, the method for transcribing DNA was first being done, they're at the same time frame, I think, in the same area of the 1900s. And so it kind of flows naturally that we would use these common words to describe these similar processes to make more sense of it. And
yeah, that makes a lot of sense. And I'll come back to that in a little bit, if I may, because one of the things I think we need to do is to sort of explain to the general public and give a better sense of what actually is happening with the science. And if we use terms that we understand in different areas and they're not inaccurate, no problem. Wanted to talk a bit about rapid response and your work there. Could you tell us a bit about what it involves?
Right. So unlike the traditional definition of rapid response, we're not a group that will drop into the middle of an outbreak to respond to it. We don't have go bags under our desks to immediately respond. Our idea of rapid response is a little bit different. It's about being able to generate tools or reagents that the folks on the ground can use to actually do their jobs better.
Right. So it's sort of more in the lab, more in the science, yes, rather than, and there's I can see how we would prepare for some of our old enemies, a new strain of TB or HIV, or some of the diseases we'll come on to in a minute. But how does it make sense to prepare for something that we don't know is coming around the corner? How do we prepare for the unprepared?
Yeah, that's a great question. And I think, one of the things, I think preparedness is the key. And how do we do that? Well, I think just by giving people the tools to better address the public health questions that they have on a daily basis, because that will help them understand how things are evolving and what's coming potentially, so that they are more prepared. Giving people the information in real time or near real time instead of waiting or having to wait a long period of time to be able to make better decisions for resource allocation and things like that. So that's very empowering.
So the Biohub has two presidents, and Joe DeRisi is one of them, and he did to me a very clear sort of explanation of what the Biohub was doing: detection, respond, treatment, and prevention. And the thing I loved about it was that detection was at the front. And I think about the HIV world and how we have prioritized treatment. And one of the other things that you at the Biohub are doing is sort of expressing a frustration with the status quo. And I know you guys use Zika as the example of sort of how not to do things. But the idea of speeding things up, not being constrained by getting grants in and, the whole process that goes with that. And I think all of us would share that frustration. But how are you going to address that?
Yeah, I mean, I don't think we're trying to make an end run around anyone. I think what we're trying to do is really we want to partner with people, and we want to help, give people tools that they can use to help, advance the research that they're doing, or, the medical research that they're doing. And I think that's a really important aspect of it. I think, again, we want to partner and we want to be collaborators to move forward. We don't want to do it on our own because nobody can do it on their own.
Yeah. And I think there's a sort of nobody else is doing this in quite the same way. So you can see how this fits in. What was it about the Zika response that you felt was lacking?
Yeah, I think one of the biggest things that we've learned, I think, from the Zika response is that communication is key, and getting the information out there is also key to help organize and to really properly address the epidemic that was already happening, that we were quite in the middle of once we were aware of what was going on, and prevent it from being even larger than it could have been.
Yeah, and something similar with Ebola as well.
Absolutely.
I think it brought out the best and the worst in us. I mean, the worst was the really unacceptable delay that WHO had in calling attention to the outbreak in 2014 in Western Africa. But then, just later that year in Nigeria, one person flies into Lagos, and then this whole mobilization of the public health machinery comes in, and by September 2014, Nigeria is Ebola free. And I just, I think there are many countries in the so-called industrialized world who could learn a lot from that. What do you think we've learned from Ebola?
Yeah, again, I think it's about that communication and that sharing of information, not being afraid to share that information, because it's going to do more good in the end than it's going to do more harm. I think people are very protective of what happens within their borders, and they're afraid of how that's going to be perceived. And again, what we're trying to work on is establishing those information networks so that information gets out there quicker.
And there's also a protection, I suppose, in terms of the information itself. We very simplistically think of the patents and, universities and pharmaceutical companies here in the industrialized world having control of it and not sharing that information. But the Biohub is going to make all of that information that you discover readily available for everybody.
Yeah, we're all about open science. Everything we do is completely open. Any reagent we make is completely available for free. We don't charge anything for what we do. And we hope that it sets a good example for everyone else going forward. And, it's a stipulation for the investigators that we fund that they publish immediately in an open source journal up on bioRxiv, for instance, get their information out there quickly before going to a regular journal, because it's about getting that information out there as quickly as possible. Yeah,
absolutely. And then there's another, the other element of it in terms of getting that information out. It's not just the scientists, it's the community themselves. And, again, Zika and Ebola are good examples of this. How you develop technology, but explain to people how to use it and how they can incorporate it. To what extent has the Biohub given thought to how to do that?
Yeah, we think about that a lot, and actually my group specifically, because we do train people on sequencing technologies is one of our big focus right now. And so we think a lot about how that's presented and how people think about the science that they're doing in relation to the technology and what types of questions they can answer with that technology.
So again, to help us ignoramuses, sequencing technology, what does that involve?
So next generation sequencing, everyone is familiar with whole genome sequencing. So if you've ever swabbed your cheek and sent it away and mailed it away to one of these companies that will tell you all the different genes that you have or don't have, what's different about what we do is it's still next generation sequencing, but we do metagenomic sequencing. So we're actually able to look at all of the genomes, not just one, being the human genome, that's in a biological sample. So if a person comes into the doctor's office that's sick and you swab the inside of their nose, you can then amplify not only the human DNA that's there, but also the microbiome that's in the nose, as well as any infection that the person might have.
And then be able to identify what that infection is very rapidly. Yes, I sent my swab away to, I think, a lab in Oklahoma and came back half Chihuahua and half Jack Russell. But anyway. And again with Ebola, you think of two extremes: people dressed in or doctors dressed in hazmat suits coming into villages, and the extreme reaction that caused, and even violence to this day. But then you also have these leaders in the community, the elders, sort of persuading people, instead of hugging to say hello, to elbow bump them, and it sort of makes me think of the, as well as the technology, there's some really simple human ways of communicating and getting people to do things.
Yeah, I agree. I mean, our good friend Heidi Larson, right, does this all the time, and that's and I really admire what she does, because she works towards understanding kind of the cultural norms and what's expected, and is able to use that for proper communication in instances like this.
Yeah, and Heidi Larson, of course, from the London School of Hygiene and Tropical Medicine, looking at vaccine hesitancy, as she politely calls it, which is basically these anti-vaxxers. And they have their home, I guess, partly here in the Bay Area. That has been an extraordinary thing. And changing behavior, it seems, sort of relies on things as old as humanity, our beliefs, our storytelling. And I think what is really interesting is the way in which new technology is enabling us to come at storytelling at different ways, social networks, even podcasts like this. And so I really wanted to get your sense on it. There are two areas actually that really bother me. We've covered one of them, which is the vaccine hesitancy, but the other one is Hollywood and the way in which when it comes to apocalyptic pandemic movies, we always have a virus or a bacterium that kills people in less than 24 hours, and suddenly you're then left to fend, the survivors are left to fend for yourself. Do you find that frustrating?
Yeah, I find a lot of science communication frustrating. I think as scientists, we need to do a better job at communicating with the public about things. And I think that is the source for a lot of confusion and misconceptions.
Do you think we dismiss science because we don't understand it, or we don't like what it's saying to us?
Yeah, I think it's definitely, again, down to the proper communication with people and explaining things. I think what folks, what's harder to understand is science is not 2 + 2 = 4 every time. We're constantly learning new things, and with technology advancements, we're able to ask questions in new and different ways. And that gives us new information, and the puzzle pieces become sharper edged and clearer and fit nicer. And we either realize, yeah, we were right about this, or, oh, we were actually a little bit wrong. We need to go this way, and this is the way things are working. And that's constantly evolving. So the better we get at asking questions, the better information we get, the better the picture resolves for us to see. And I think because a lot of people think that, oh, you're always changing your mind, or there's always different nutritional recommendations. And it's because it's constantly evolving and changing.
Yeah, and I think people in the communications and advocacy field, like myself, we have a responsibility to be explaining that this is not, binary in the traditional sense of on, off, black or white, but there is an evolution here. One of the things I wanted to talk to you about, talking about science communications, is an author I know we're both very passionate about, chance for us to get nerdy, Margaret Atwood. Oh, yes. And so not The Handmaid's Tale, which is brilliant in itself, but the trilogy Mad Adam, which was about a crazy scientist who didn't like humanity and the way it was destroying itself. So he managed to create a pill. What was it? Bliss Plus.
Bliss Plus.
Yeah, and he managed to get, and people literally fizzled away. And he then created this benign but sort of slightly clueless,
but lovable.
The Quakers, this group of humanity who were, going to survive in the planet, and a few remnants of this sort of crazy religious environmental cult. So 3 books. I got to ask you, which of the 3 was your favorite?
Oh, that's a hard question. Gosh, because I liked each of them the best as I was reading it.
Right. Well, I got to tell you, my favorite was the middle one, A Year of the Flood, because of this crazy environmental cult. And at the beginning of each chapter, the gardeners, and they kept singing hymns at the beginning of each chapter.
Right. That's right. I forgot about that.
But then you also have the craziness of the, the large medical corporations in the first book and the work they were doing. Did this sort of resonate with you as a potential risk that we need to be aware of as we grow and evolve, or was it just good storytelling?
It's good storytelling, actually. But I mean, I love books like that. I think, as far as a worry, I think, again, the common theme for me is about communication, and that, as we move forward and we progress and we gather more information, that we don't share that information with each other, because I think sharing it is going to help us move along and prepare us for whatever might come in the future, if anything does, much better than keeping all that information close.
Yeah. So a few final questions for you, and I bet you get asked this a lot. What's your biggest pandemic fear? What keeps you up at night?
Yeah, again, it's like what I was saying, that something happens and we don't know about it because people are not owning up to what's going on, because they have some fear for whatever reason that it's going to be looked on in a bad way. And I think that's really kind of, there's, the world is changing and there's always potentially some danger out there. But in order to be prepared, and in order to be able to face that in the best way we can, we really need to trust each other.
Yeah. So in a sense, it's not a virus or a bacterium. It's not a bug. It's the way we handle it. If you weren't a scientist, what would you be doing?
I would either be an anthropologist, which is kind of still a scientist, but is a scientist, but maybe a writer.
Oh, yeah. I can totally see that. Yeah, absolutely.
Again,
Margaret Atwood, watch out. And then finally, so you work in a deadly serious environment. I mean, at the Zuckerberg Biohub, you have laboratories there that you work in, and yet, as we've got to know each other, it's clear you have such an optimism and a positive outlook on life. How do you stay positive?
I definitely think it's the people that I get to interact with on a daily basis. It's an amazing place. I've met so many really intelligent, brilliant scientists from all different disciplines, ecologists, engineers, biochemists, and they all come together and we all talk about these common issues. And they all have a different perspective. And it's just really exciting to hear those different perspectives and see how we can work together to kind of solve some of these problems. And so it's just a lot of fun and just interesting every day.
Well, Cristina, it has been an absolute honor having you on the show this week. Thank you so much. Please keep us informed of your progress and what you get up to. We'll be watching you very closely. Cristina, you are a shot in the arm.
Thank you.
Well, that's it for this week. Hope you've enjoyed the show. We'd love to know your thoughts, the areas we ought to cover, areas perhaps that we've missed. Feel free to contact us at Twitter and Facebook at Shot Arm Podcast. A final shout out to The Watchmen, a new series on HBO that is actually pretty watchable, so binge watch that. And a thanks to our team here at A Shot in the Arm podcast. Thanks to Eric Espera, our director and producer. Thanks to Brian Regus and Will Lansdales. So, have a great week, everyone.